So today we'll be talking about population dynamics in ecology. So population is basically a group of individuals of one species that interact. How often? That depends on the geography. If the individual are close to you, you're going to interact with him and compete for mates and food. If it's far, so you won't interact too much. Also, another thing that affects population is density. How many individuals come in contact with each other? So that's it. And also dispersion, if they are all tucked in the same place, or if they are dispersed one from another, one far, far away. And in 2016, there was in Dallas, Texas, an outbreak of mosquitoes. And why did that happen? So, what affects population with our density? It gets higher when individuals are born or immigrate, and decreases when individuals die or emigrate. Also, fecundity. The mosquitoes, they have around 2,000 babies in their 2-week lifespan. We also have limiting factors, which in that particular year were not limiting anymore. That's why there was that great outbreak. So food, the females, they suck blood out of vertebrates. And let's say that year there was not more human population. Let's say it was the same. It was constant. The temperature arose in Dallas, Texas, in that summer was very, very exceptionally hot. And they also needed space. The females, they lay their eggs on stagnant waters. And in that summer, it rained, and there was lots of stagnant waters. So they had temperature and space in their favor. So that's why they broke the record of babies. And we can have a little flavor of that. So we know that the final population is going to be the births minus deaths divided by the population, the initial population, or normally it's written as only n. So let's say we had 100 mosquitoes. That means that the deaths were 100 and the births were, say we had from those 100, 50 were females. So it's 50 times they make 2,000. So that's going to be equal to 10,000. Is it? So it's like this, okay. So then P is going to be equal to births, which is 100,000, minus deaths, which is 100, divided by 100, right? So 100,000 minus 100 is going to be 9,990, which is divided by 100 is 999. So it passed from 100 to 999. That's a 998% increase. And this type of animals, we have something that's called R versus Q. So let's say you go in a restaurant and you can have noodles, cup noodles, or you can have organic pasta from Italy, from from Italy. The noodles and pasta, they are basically the same thing, but the noodles, they come in more quantity but less quality, and the pasta comes with more quality but less quantity. R is quantity and K is quality. That applies also to the animals. They have a spectrum. So normally the animals that are the little animals, they like to have many babies because, or should I say, offsprings, because it's not known if they're going to survive. So they take little to no effort in making them, and they just hope that at least one survives. And the K is the one that puts a lot of energy growing only a few babies. And a good example is the R would be the mosquitoes and K would be the humans. And the K, they tend to reach the limiting, the carrying capacity, because the R, they make a lot of mosquitoes. So the predator of the mosquitoes, they grow. And then what happens is that the mosquitoes, they decrease their quantity. So they are never going to hit the carrying capacity. While the humans, for example, their carrying capacity was from 1 billion to 1 trillion, which is 100 billion. So yeah, but actually Leeuwenhoek, he studied and he said there was about 10 to 15 billion people. So after that, we're not going to have enough food, water, temperature, space for everybody. I mean, we could like put a bunch of people in a 12-meter square place, but it wouldn't be good.